So we're going to look at systems, and we're just going to do a review of two variable systems. And what these are would be something, say, like this. And so what we want to do is we want to come up with an x value and a y value that satisfies not just one of these equations, but both of them. So there's an x and a y value that will satisfy this equation, and those same values are going to satisfy this equation also. So let's say we try this. Let's guess. Let's say 1, 0. Does this work? Or let's try a different one. Let's say we've got, I don't know. Let's see if we do that. Let's say 5, 2. Let's try this. So if we try the first equation, we'll get 5 plus 3 times 2. And sure enough, that does equal 11. So it satisfies the first equation. What about the second? We get 5 minus 5 times 2. It's going to be 5 minus 10. That's negative 5. We needed to get negative 13. So this is not a solution to the system. Again, it has to satisfy both equations. So let's try 2, 3. Let's try that one. So let x be 2. We get 3 times 3. Again, this is this first equation. And sure enough, that gives you 11. Now let's try this. Second one, 2 minus 5 times 3. It's going to be 2 minus 15, and that gives you negative 13, and that also works. Well, since this point satisfies both equations, it's a solution to the system. Now, in this section, we look at finding solutions through two methods. Now, another method they don't mention is you can graph. What these equations are, they're lines, they're linear equations. So if you graph these, what you're going to get are two lines. And just say you had a system of equations, this could be your first line, and this could be your second line. The system solution is where these lines cross. The reason that's the case, remember, the solution to the system has to satisfy both equations. It has to work for both of them. So here are all the lines that satisfy, well, this red line. But they're the points that satisfy this red line only. These are the points that satisfy the blue line only, except for one. Where these cross, this is a point that satisfies both lines. So when we're graphing these, where they intersect, that's the solution to our system. So in our previous example, if we were to graph those two lines, we would find out that they intersected because the solution to the system was 2, 3. The two lines would intersect at the point 2, 3. But that's something we're not really looking at in this section. This section, we're mostly interested in just finding algebraic solutions, or finding the solution algebraically. So what we're going to do is look at two methods that you can do this. And the first one is called substitution. Now, substitution is we replace a variable with another variable. And the goal is we want to come up with the equation that has only one variable. When equations, if a single equation with two variables, well, I mean, we can solve for one of them, but we're not going to get a number. But if we have one equation with one variable, when we solve for that variable, we're going to get a number. So let's say we have something like this. Now, we have two variables, and we have two variables. So here we've actually solved for one of the variables, but we're getting an expression with an x in it. We don't get just a number by itself. So the idea of substitution is this. Replace one of these variables, and we're going to replace it with an expression that contains that variable. Now, this has already sort of been done for us. Someone has already gone ahead and solved for y. So we can replace y here, and we'll get 3 times, and then y, it's the same as that. So you get 2x minus 9 equals 8. So we're taking this equation, we've got the x, we've got the 3, we replace y with a sort of alter identity. It's sort of like its Batman costume, so to speak. And then it's equal to 8, equal to 8. Now we have an equation with one variable. Combine these. Add 27 to both sides. Divide both sides by 7. And that is what we get for x. So x is going to be 5. Well, now we got to find y. Well, we have an equation or formula for y. We just need to put our x is 5 in that formula. So we have 5, comma 1. And so that's the solution to that system. So that's a method of substitution. Now you might have to solve for y first. Sometimes that does happen. So just keep that in mind. Let's see if they have an example. They don't seem to be really having you do too much of that here, but there's a couple. Like, let's take a look at this one. Now, in this case, we want to solve for one of the variables. Now, I'm going to actually solve for x. So I might add x to both sides here. That makes that negative go away. Subtract 8 from both sides. And now we have an expression for x. So what we can do is go back to this equation. If we've used this equation to solve for x or y, we want to substitute into the other equation. So now we know x is equal to this. So that means we can replace this x with this. Multiply through by 2. Add 16 to both sides. Add 12y and 5y. Divide by 17, and we get y equals 1. So that's part of our solution. Now, I erased my equation here. The equation we had for x was that. So now to find x, we just substitute y as 1. If minus 2 equals x. And that's going to be your answer. So that's the method of substitution. The other method we're going to look at is addition. And again, it's the same idea. We want to try to take these two equations, each of them has two variables, and come up with an equation that has one variable. And this is a different way of going about it. What we're going to do is add the equations together to get a third equation. And when we add them, hopefully one of the variables cancels out. So for example, let's say we have this. Now we keep the equal sign. And we're going to add up the right side, and then we add up the left side. Now the right side's going to be 1 plus 3. 4. X plus x. And we want to add the same variable, It's like combining like terms. X plus x is 2x. And then y plus negative y is going to be 0. Or 2x equals 4. And so what happened is that the y's, when we added these two equations, they canceled out. So that leaves us 2x equals 4. Divide both sides by 2, and there we go. We get x equals 4. Now we got to find y. Well, what we can do to find y, x equals 2. There we go, that's better. So x equals 2. I'll put that up here so I don't forget. So what we can do, we can take either of these equations, replace x with 2, and solve for y. So I'm just going to go with this one. So got x plus y was equal to 1. Now this is 2 plus y equals 1. Subtract 2 from both sides. We get y is negative 1. So the answer for this solution is 2, negative 1. And that's it. Now let's do one that's a little trickier. Let's see. Let's say we have this. Now, if we think about adding these, if we do, what we're going to get is 27, 5y, and negative 3x. Nothing canceled. So what could we do about this? Well, what we can do is we can multiply both sides of one of these equations. Because remember, you do the same thing to both sides of an equation. Okay, it makes the equation look different, but it's still balanced. And as long as it's still balanced, it's still legitimate. So we could multiply both sides of this equation, maybe by some number. And you don't have to just multiply. You could try dividing as well. I'm going to go with multiplying. I think it's going to be easier in this case. Could we multiply both sides of this equation by some number that's going to cause either the x variable or it might cause the y variable to cancel? Well, what about this? What if we multiplied both sides of this top equation by 4? If we do that, you'll get 4x plus 2 times 4 is 8y equals 2 times 4 is 8. But what's going to be important, we'll have 4x here if we multiply everything by 4. Excuse me. And 4x, if we add it to negative 4x, that's going to cause the x variables to cancel. So what we'll do, we'll take 4, multiply it to both sides of this top equation. And so that's going to give us 4x plus 2y equals 8. So this has now become that. We multiplied everything by 8. And again, we did the same thing to one side as we did to the other. So this is perfectly fine. Now we take this equation, the second one. Oh, and this is 8y. Forgot to distribute my 4 there. So 4x plus 8y, need to distribute, equals 8. Now when we add these two equations, these will cancel. This becomes 11y, and this becomes 33. Or 11y is 33. Divide both sides by 11. We get 3. So we found out y is 3. Now what we can do is we can take any two of these equations, any two of the original equations, replace y with 3, and then solve for x. So let's go with the second equation this time. So 4x minus 4x plus 3 times 3 is 25. Minus 4x plus 9 is 25. Subtract 9 from both sides, we'll get minus 4x is 16. Divide by negative 4, x is negative 4. Oh, I'm sorry, positive 4. So, no negative 4. Right? Yeah, negative 4. There we go. So x is negative 4, y is 3. And so that means the solution is negative 4 and 3. Now I've made some mistakes in my multiplication, so let's check to make sure this is correct. And again, to check the solution, it needs to be correct for both equations. And this can happen. If you're working on these problems, maybe you're really tired and you start finding you're making mistakes. Try testing your solutions, check your answers. So for this first one, this is x and that's y. So negative 4, 2 times 3, does this equal 2? We'll get negative 4 plus 6, and that does equal 2. So we're okay on the first equation, but we've got to be okay for both. This means negative 4 times negative 4 plus 3 times 3, does that equal 25? Or 16 plus 9, that does equal 25. So it checks out. So this is a solution to the system. Another type of addition problem you could get, we might have to multiply both equations by a first number and then a second number. So let's say we have something like this. Now again, if we try to add these, we'll get 5x negative 4 plus 3 is y, and this will be 11 plus negative 4 is 7. But we'll get 5x minus y, actually, we'll get a negative y here. So 5x, a negative y, and a 7, nothing cancels out. And if we think about it, well, golly, I can't think of a single number I can multiply both sides of this equation by that would, if we added afterwards, it would cause cancellation. And I'm going to kind of be easy on myself with this. I'm thinking in terms of integers. What integer could I multiply by? I'm not thinking about fractions or decimals, though you could do that. Well, how about this? What if this was 6 and this was negative 6 instead of 3 and 2? In other words, I multiplied this whole equation by 2, multiplied both sides by 2, and multiplied both sides of this equation by negative 3. If we do that, 6x minus 8y equals 22. And then applying negative 3, and we're applying it to the second equation. Well, if we multiply through, we'll get negative 6x minus 9y is positive 12. So now our system of equations has gone from this to this. And this is perfectly fine, as long as we multiply both sides of this equation by the same number, and both sides of this equation by a second same number. So we multiply both sides here by 2, multiply both sides here by negative 3, and that's going to work. So what we get at the end is 6x minus 8y equals 22. Negative 6x minus 9y equals 12. If we add these together, well, this will add to 0. This will be negative 17y, and this will come out to 34. Divide both sides by negative 17, we'll get y is negative 2. So finally, we have y, we just need to find x, and really we could use any of these 4 equations to find y, or find x if we want to. I'm just going to go with this one here, but we could have used any of these 4, it would have worked. Subtract 8 from both sides. Divide both sides by 3. And that's our x value. So the answer to this solution is 1, negative 2. And that's it. So if you have any questions, let me know.